So our next problem, we're going to find domain again. This time, instead of dealing with a square root, we have one where we're going to have to deal with a fraction. So find the domain of the function. What are the x values we can plug in? The only thing we can't do on this problem is divide by 0. So if we want to find the domain of one with a fraction here with x in the denominator, we need to set that equal to 0 or figure out what would make that 0. And our domain is everything except that. Okay, so it's all real numbers except whatever values, in this case, make x squared plus 9x minus 22 equal to 0. And we can factor that one into x plus 11 times x minus 2, since 11 times negative 2 will give me negative 22, and then 11 minus 2 gives me 9 in the middle. So if we set those equal to 0, we get negative 11 and 2, and those are the values that we cannot have. Our domain is everything, all real numbers, except negative 11 and 2. So in interval notation, that's everything up to negative 11, negative infinity to negative 11, parentheses to not include the negative 11, and then I've got my union symbols here, negative 11 to 2, and then 2 to infinity. So if we want to throw out those two numbers, chops the number line into those three intervals. Next up, we're going to look at domain and range on a graph. So I picked this one from the book, problem 126. So if we want to find the domain on the graph, we have to look what are the x values for all the points on this graph. Okay? So I used to describe it as, say, make vertical lines and see where you hit the graph, or maybe take your pencil and lay it there vertically and see where it hits the graph. How far can I go to the left? How far can I go to the right? Another way I've thought of describing it, if you could smash this graph onto the x-axis. That's what I've tried to kind of draw here. If you just took the graph and compressed everything down onto the x-axis, you'd see the domain, and we'd have a big closed. I probably should have put a closed endpoint here on my drawing, but the domain is going to be from negative 4 to infinity in the x direction. We can go as far as negative 4, including negative 4 because we have the closed circle. And then in the other direction, we can go off to infinity. So our domain is negative 4 to infinity. You look left and right on the graph and see what are all the possible x values on this graph. For the range, you look in the y direction. What are the possible y values? How low can you go? How high can you go? Or smash that thing onto the y-axis and see what happens. We can go from negative 2 to infinity. This is our lowest point, which is at y equals negative 2. And then we've got an arrow going up and up and up. So negative 2 to infinity would be our range. Brackets on both of the endpoints there because they're corresponding to that closed circle at negative 2, or at negative 4, negative 2. So negative 4 is in the domain, negative 2 is in the range. Let's see, next up, piecewise functions. We want to be able to evaluate them as well as graph them. On the test, I'll give you one piecewise function similar to this one where it'll be two linear pieces. And I'm going to ask you to evaluate it at 1, maybe 2 points, and then also draw a graph. Okay, so I'm going to do both of those things with this one. So first of all, actually, I may draw another one, but anyway, this one, number 46, says to evaluate it f of negative 3, f of negative 2, f of negative 1, and f of 0. So the thing about a piecewise function, it's a function, and the rule you use depends on the domain. If you're trying to evaluate this one for an x value less than negative 2, then you use x plus 1. But if your x value is bigger than or equal to negative 2, you use negative 2x minus 3. So if I wanted to do f of negative 3, that's saying the x value is negative 3, and I make that decision right at the beginning. So negative 3 is less than negative 2, so we're going to use the x plus 1 piece. So f of negative 3 would be negative 3 plus 1. I plug it in for that x, and we get negative 2. Negative 2 satisfies that it's greater than or equal to negative 2 because of the or equal to part. So we're going to use the negative 2x minus 3 to evaluate that one. So negative 2 is greater than or equal to negative 2, so we use negative 2x minus 3. So we do negative 2 times negative 2, if we're plugging in x equals negative 2, minus 3, which will be 4 minus 3, or 1. Negative 1, the other two, negative 1 and 0, are both bigger than negative 2, so we're going to use the second piece again. So for negative 1, we plug it into negative 2x minus 3 because negative 1 is bigger than negative 2. So we get negative 2 times negative 1 minus 3, which, let's see, did I mess that one up? Yeah, I did. That's going to be 2 minus 3. That should be negative 1. f of negative 1 is negative 1 because that's going to be 2 minus 3. I don't know what I did there. And then 0 is also bigger than negative 2. We plug it in, we're going to get negative 3. So make sure you notice that one's a typo. I'll fix it on the notes here, but that should be negative 1 on that one. There, I was able to pause it and fix it here. All right, so there's the correct answers on that one. Let's see, it actually is the same function, different problem, but the same function. We're going to graph it here on this exercise. We're going to graph f of x as x plus 1 if x is less than negative 2, and negative 2x minus 3 if x is greater than or equal to negative 2. So if you have one that's two pieces and they're both linear, I usually make a couple of tables with 2 points in each table because each piece is a line. And I'm going to plug negative 2 into both of them because that's the boundary point where it changes. So first I would make a table for x plus 1, and I would include negative 2 plus some number less than negative 2, and I just pick negative 5. Okay, so I plug those into x plus 1. So negative 5 plus 1 is negative 4, negative 2 plus 1 is negative 1. Now negative 2, negative 1 is going to be a big open circle on the graph. It's an endpoint, but it's not included because this is for x less than negative 1. When I plug negative 2 into the second piece, that's where I'm going to have my closed circle on the graph. So I went ahead and did this piece. So I always make a little dotted vertical line where it changes. It's not an official part of the graph, but I think it's very helpful. This graph changes shapes at negative 2, so x equals negative 2. I put the dotted line. We've got negative 2, negative 1 is going to be our endpoint here where this one hits the dotted line. That's an open circle because we're going to jump to the other function at negative 2. That's not the function value there. It's the endpoint that we need as an open circle, but it's not the function value, so we leave it open. And then our other point, negative 5, negative 4, is just a regular point on the graph, and then we draw our half of a line going this way. And then we're going to draw negative 2x minus 3 on the other side, so I need a couple of points. Again, I'm going to use the boundary point, negative 2. I plug that in, this time into negative 2x minus 3, and I get 1. And then I picked 0, a nice easy point to plug in, which is over here greater than or equal to negative 2. Plug that in and got negative 3. So I plot my points. My 2 points there, negative 2, 1. That one, oh, that should be a big closed circle on the graph. This one should be closed in. Okay, so filled it in there as best I could. So this one, so we've got the point negative 2, 1. I always notice my mistakes here when I start going through these and working them out. Negative 2, 1, we got the closed circle. And then 0, negative 3 is another point on the graph, and we draw the half a line. So I have these two half a lines. Together it's a function. It has to pass the vertical line test. Over here it only hits this piece. Over here it only hits this piece. And at x equals negative 2, it only hits the closed-in circle, not the open circle. So that's how I graph a piecewise linear function. I make two tables, I plug in the boundary point, in this case negative 2, into both of them, and that's where I get my open and closed circles. The one that has the or equal to gets the closed circle, the other one gets the open circle. And then we need at least 1 point on each side there to finish drawing the picture.